Okay, so good morning, everybody. Thank you for coming to this session instead of attending the Open Edge roadmap. So you probably heard everything. So this session is an introduction to Git. That will not be exactly the same as the other sessions that you can see on YouTube. I didn't want to do exactly the same thing. So I personally moved to Git a couple years ago, and I did it the wrong way. So I just wanted to teach you what saved my life a bit too late, but at least that saved my life, and how to understand how Git is working, and that will help you on the long term. So there might be some technical details, but that will be extremely useful on the long term to understand how Git is working and how to work with Git. So just one note first. From 2010 to 2024, this is a Stack Overflow trend of the how many questions are asked on separate topics. So just to give you the trend, SVN was 1.6% of the total questions on Stack Overflow in 2010. It's now down to 0.01, something like that. This is approximately the same for every other source code repository on the market. So Git just crushed the competition. So there is nothing else apart from Git in the code repository ecosystem. So now, if you start a new project, you don't ask yourself any question, just use Git. That doesn't mean that you have to switch to Git if you are using something different. Switching to a new source code repository is a time-intensive process. This is not something that you can do in a couple minutes and say, hey, this is a new code repository, we did the migration, here you are, help yourself, and that will work. This is a process that will take a couple months at least to correctly train your developers to, is that okay? That so it's a process that will take some time. It will take you a couple months to get ready to do the migration and to have your developers ready to work with the new code repository and have your managers and release manager able to work correctly with the new code repository. So don't take this decision lightly. It's something that has to be prepared and that will take you some time to do correctly. So, just something, Git started as a project for the Linux kernel. So the Linux kernel was working with CVS, that was up to the beginning of the 2000s. Then Linus Torvalds, he always said that CVS was bad. But he wanted to get something right to work with the kernel, and especially in order to be able to merge changes from multiple companies into a single baseline. So many companies are working on the Linux kernel, Red Hat, IBM, Canonical, Ubuntu, and Debian. So many companies have their own version of the kernel, but then you want to integrate everything into a base version. So multiple feeds coming from various vendors, and that was extremely difficult to manage with CVS. So he started working with BitKeeper, which was a commercial product from a company by the same name, if I remember correctly. And that was a perfect product to work on the kernel. So there was only one minor issue. That was BitKeeper was a commercial product, and when working on the Linux kernel, there were so many advocates of open source that they said, there is no way I work with a commercial product, so I want something open source to work on that. And then something bad happened with BitKeeper because they were fed up of people complaining about the commercial aspect of BitKeeper, and then they said, there will be a commercial aspect because BitKeeper just offered a license to several Linux kernel maintainers. So then they turned commercial, and then Linus said, oh, okay, we just get rid of BitKeeper, but we have to find a new replacement. So this is where he started working on Git, and this is the rumor. I'm not sure if that's correct or not, but over a weekend, there was a basic version of Git working. And that was exactly with a few things in mind, the ability to merge multiple branches in an easy way, and which is still the fundamental of Git these days. So Git started only for the Linux kernel. That was a Linux-only tool, command line only, and that was in 2005, I think, if I remember correctly. At the same time, there was another tool which was started, that was Mercurial, and I personally was still working with Subversion at this time. So Subversion is quite okay, but it's definitely not okay if you want to merge multiple branches and manage that on the long term. Definitely it doesn't work correctly, it's not good enough. So then I switched to Mercurial, that was in 2010, 8, 9, 10, something like that. That was working much better than Subversion, with much better support for multiple branches. Google Code, there was something called Google Code at this time. Does anybody remember Google Code? No? Okay, that was this kind. SourceForge was one of the first open source repositories, public repositories on the internet. Then there was Google Code, because SourceForge was a pain to use. And then Google Code shut down in 2015, something like that. So I was using Mercurial, which had more or less the same concept, but for whatever reason, Git is now the clear winner of the competition on this market. So this is the standard XKCD strip. This is how many, the way many people learn how to work with Git. And definitely, in many cases, this is exactly this case. And I have to admit that I did the migration more or less in the same way. I had a choice. I could use a proper training. I didn't do that. I said, oh, I will move from Mercurial to Git. I will just follow this tutorial on the internet, and that will be fine. And so for 1 year, 2 years, no, 1 year I would say, I kept repeating the same command lines again and again, because there was only the command line at this time. And I didn't know exactly what I was doing. That was, when I was stuck at some point, I just went to Stack Overflow, typed my question, and then magically there was an answer involving a command line, an obscure command line with many parameters, typed it, oh, it works. That's nice. I'm not stuck anymore. Let's continue with development. Okay, is that a good way to work? No, definitely no. So during this presentation, I will just expose a few things. It took me, at some point, I took one entire day just to read the entire Git documentation and proceed with example. Maybe I should have used proper training. I did that myself and spent just enough time to understand how things were happening with Git. So I will expose during this presentation a few key concepts that you have to understand if you want to understand how a Git is working and what you do for what is happening when you type a command line or when you click on an action on your favorite GUI for Git. You have to understand that. If you don't do that, you will just repeat the same basic steps again and again and again without understanding what's happening. So just take some time to understand that. So those are the top 3 things that you have to remember when you work with Git. So first, a commit, as opposed to Subversion, a commit is Git, is an entire snapshot of the entire directory that you have. So you take a picture of all the files, everything that is managed by Git, so all the .p, .cls, .df, .whatever, .txt, you take a snapshot, take a picture, and this is stored in the repository. This is a commit in Git. This is not the difference between one version or another. This is a snapshot of an entire directory. You just do not have to care about the size it takes on the disk. Then, because there are some optimizations so that it doesn't take too much space, and if you have a very large repository and then another commit, another commit, another commit, it won't take 4 times the size of the entire directory in the Git repo. This is optimized by Git, but the definition of a commit is an entire picture of the entire directory at a point in time. The next thing that you have to remember is that a commit contains a picture of the entire directory and a link pointing to the parent, saying that the previous snapshot was this one. You have an identifier to attach to a commit. This is a commit ID. And then another commit says, this is the entire snapshot. This is my parent. Or I have multiple parents, this can happen, or no parents in very rare cases. This is the initial commit. When you initialize your repository, the initial commit doesn't have a parent. But usually, one commit, entire snapshot, one parent. And then, every time you execute a Git command line, you are just manipulating a tree. You always have to keep in mind that when you execute a command line, you are doing something with trees and leaves and branches, and you just manipulate a tree. So you have to have a view of the tree and see, oh, okay, this command line is moving this file or this commit to this location, or I'm modifying the content of this snapshot. So you manipulate trees. Everything is that. So the first thing about a snapshot. So if we have a very simple repository here, we have 2 files, file 1 and file 2. They have exactly the same content. This is important. Then you do move file 1 to file 4 and file 2 to file 3. So you just rename files. Okay, then you execute the git add so that this goes into the staging area. We will come back to this topic a bit later. And then you type the git status just to see what is pending, what are the pending changes in my repository here. And you can see that file 1 has moved to file 3 here and file 2 to file 4. So technically, this is not what you have done. But you are working with a snapshot. The file content is identical. So whether it's file 1 or file 2, which has moved to file 3, that doesn't change the end result. You don't track file renames. You just have a snapshot, and at some point, there was file 1 and file 2 with this content. At the end, you have file 3 and file 4 with the same content. So you will take a snapshot, and Git will guess and say, oh, if I move file 1 to file 3, it's okay, it works. This is the end result will be exactly the same. So there is no command line to say, I will want to move one file to a different location. You just move the file at the operating system level, and then you tell Git, please keep track of those changes. Okay? So it's a snapshot. At the end, as long as the end result is identical, Git doesn't care about moving files. And here, so same, we start from nothing. We have file 1 and file 2. Then file 1, we just add 1 line. File 2, we add another line. And then we move files around. And then, as you can see here, we just modify the file content, and again, we end up with something which is not what we have done. So technically, we added line, moved the files around, deleted another one, but then the end result is okay. So we do not care about the command lines. This is just the end result that is important, and that will be the snapshot that will be recorded by Git. Then Git is working with a directed acyclic graph. So here there are two options. So we have the time going from left to right, and this is option number 1. This is how commits could be organized. Option 1, option 2. Which one is correct in Git? Who is in favor of option 1? Who would say option 1 is correct? The way Git organizes commits. 1, 2, 3, 4, 5. Option 2. 1, 2, 3, 4. It's okay. So this is what I said at the very beginning of the session. Commits knows parent. So this means that option 2 is correct. You have your commits and you know the parent, so what was done previously. And it's absolutely important to remember that a commit never knows anything about children. It never knows about children, only about parents. So one commit, if you have one commit, you can get back to the beginning of the repository because you know the parent. So if myself, I know my parents, so I can go back to the beginning of the civilization to just by assuming that every person on Earth knows his parents. You will miss a few people. For example, I will miss my cousins, for example, because my parents don't know about their other children. So I wouldn't know about my sister because I have to go to my parent, and then my parent don't know about the other children. Okay? So you can get back to the beginning, to the origin of the world by going back to the initial commit that started your history here, but you don't know every single branch. A branch is one way to get back to the origin of your repository. The initial commit, the one where you typed git add a bunch of files, and this is the git commit initial import. This is when you moved from Subversion to Git, for example. So you never know about children. This is something absolutely important to remember. And yeah, Ken Beck had this thing about Git is about manipulating trees. So you create nodes, you move pointers around. That's extremely important that to see what is happening at the tree level when you work with a Git command line. A few other things is about using the right tools. It's important everywhere. We are IT professionals. We have to use the right tool whenever working with something. So on the client side, for people already working with Git, what are you using for the GUI side of Git? Git extensions? In VS Code, you mean? Okay, in a developer studio and or Eclipse or IntelliJ and VS Code. Okay. Okay. Yeah. Anything else? No, you don't really use Git. So a few tools that you can use. Source tree here is coming from Atlassian. It works quite well. I don't like it, but it works. Then you have GitHub Desktop. It works. I absolutely dislike it, but it works. Then you have VS Code, where you can add some extensions. There are a few good ones. GitLens is probably the most widely known. I guess it turned commercial a few months or years ago. I don't remember exactly, but definitely my favorite one is Fork. So you just go to fork.dev. It's a commercial product, but the license is 50 euros per user. So I would say almost nothing for, if you compare that to the developer price per hour, 50 euros is absolutely nothing. It is well maintained, it is very close to the command line, and you always understand what is happening at the command line level, and it offers so many good options that definitely have a look at this product. It's, to my mind, the best one. It works on Windows, on Linux, no, on Windows and on Mac OS. Then if you want to work with the command line, you have to use extensions. So if you are working on Linux, you can use a Z shell, which is a default one in macOS, but you can also use that on Linux. Definitely, if you are still working with SH or KSH or even Bash, you can use Z shell, which is much better and much more powerful. And especially with the extension like Oh My Z shell, where you can add your prompt will be expanded, and you will have all the information, all the required information when you are, for example, connected to a remote SSH server, when you are inside a Git repository. You will have a lot of information on the current directory, the current platform you are working on. It's definitely useful. So have a look at that, use Z shell. You can even install that on your servers. It just works, it's really good. You can use Commander, but it's now more or less dead, I would say. On Windows, my favorite extension is now to use the Windows terminal, and then you can use Oh My Push. There is this article coming from Scott Hanselman, a famous Microsoft engineer. This guy is really a lot of interesting topics on his blog. So this describes how to use the new Windows terminal in combination with Oh My Push, where you will have a lot of information about the Git repository that you are working on, if there are pending changes and so on. So without having to type command lines, you will directly see the status. Have a look at that, it's extremely useful. So again, on using the right tooling, on the server side, Git, technically, this is just a directory sitting on a server, nothing more than that. In order to push changes into a remote repository, you just need an SSH connection going to this server. So there is nothing has to run on the server side. No process except from OpenSSH to have a server running. So you just need a connection. However, almost everybody is using a server-side extension in order to have a view, in order to use your web browser to browse and navigate the remote repository, in order to have access to pull requests, in order to have access to merge requests. So there are currently 3 major vendors. There are many others, but there is GitHub that you can use directly online. There is also an enterprise version of GitHub if you want to pay quite some money. This is quite expensive. I would say this is for very large organizations who absolutely do not want to put any source code outside of the company. So if you have this requirement, you may have to use GitHub or Bitbucket coming from Atlassian. If you are in favor of the entire Atlassian stack, then it might be a good choice, especially because you will have the integration between all the tools with Confluence, with Jira, with the entire Atlassian ecosystem. It can be a bit difficult to maintain. It requires a lot of work. It can be painful at some point to work with the entire Atlassian stack, but there are many benefits. And GitLab, which is the open source one, with enterprise extensions. If you want something easy to set up and that you can host internally, GitLab can be a good choice. There are even Docker images for GitHub, so in a couple seconds you will be able to spin up your GitLab instance, have it running. So it can be a very good choice. Also, this includes the replacement for Jenkins. So if you want to build your projects directly inside the same UI, you can use GitLab because you can do everything in a single location. So it could be a good choice to use GitLab. I'm personally using the GitHub on the web with an enterprise account to get there. It just works too. And no setup, nothing is hosted internally, nothing to take care of, nothing to maintain, nothing to upgrade, you don't have to care about the security issues. Everything is hosted. Then something about branches. So after the tools, we will go back to the branches. So as we have said previously, a commit is a snapshot of everything, the entire directory, and each commit has an ID and author. So the commit ID, this is this key. This is technically a SHA-256 or SHA-1, I don't remember. So a 40 characters long identifier that is unique across the repository. In order to have quick access or something which is easier to read, you just need Git will always display the short version of the SHA, and meaning that will be the usually 6, 7, 8, 9 if you have very large repositories, 9 characters that are enough to identify the commit without having to type the remaining characters. So you know that if you type up to that, that will be unique. You don't have to type the remaining one. So this is a short SHA, 6, 7, 8, or 9 characters. So this is a unique ID in your repository. So the commit contains the entire set of files, the commit ID, and then the author of the plugin. We also know that in this graph, we know that each commit has exactly one parent. So we go from here, this is a current state of the repository here. This is a parent commit, going to this one, going to this one, and going to the very beginning of the history here of our repository. Here, a branch is just a tag. There is no such concept as a branch is a set of commits, a set of differences from one version to another one. A branch is just a tag that you associate to one commit. So here, the master tag, and I should have updated that because currently, if you create a new Git repository, it will use main as a default branch and not master. So I have to update this slide. So here we are on the master branch, and we just know that master is pointing to this commit ID A72 and so on. And we can go back to the beginning of the repository. That's enough. So a branch, master branch, is this commit, and this is, if you check out a specific commit, you will have, as this is a snapshot of the entire directory, you check out something, you have the entire set of files, period. Then, when you create a new commit, so you add new files or you modify the file contents, you create a new commit with a git commit command line. What happens is that you create a new snapshot here with all the entire snapshot, so it contains your changes, with a new commit ID, a new another author, and what happens is that the tag of the current branch, the branch that you are working on, it just moves along with the commit. So instead of staying there, the tag will be brought to this commit exactly. Okay, so using now the master branch point to another commit ID in the repository here, but we still have the entire repository here. We can go back to the initial commit, and we know that the previous one was A72C95A, and so on. So we know exactly what happened at every point in time in our repository. So this is exactly how a branch can change. So you create a new commit, and the tag just moves along with the commit with you. Okay, so this is for a single branch. So then, this means that if you create a new branch, it is extremely cheap, because the only thing that you do is you create a tag. So this is just one file on the file system saying that my branch feature 1 points to this commit. So creating a new branch, that takes 1 microsecond at most. if you compare that to Subversion, where create branch, you have to go to the server and say, oh, create branch, and then it takes forever, blah, blah, blah. Here you can do that locally on your machine, and it takes 1 microsecond at most, okay? So you create a branch, and the point that creating a branch is extremely cheap. This is why Git, you always work with branches in Git, because this is extremely cheap. So you create a new one, and then that will be merged onto the main branch. So what will happen is that every single feature that you add onto your product. So feature 1, quick order form. The feature 2, the new ledger functionality. So that will be created independently from each other. So Dan is working on this quick order form. He just works at home without any interaction with Bob. So they can work completely independently from each other. And then at some point, you will merge branches. And does that still work? So you can do the test. This feature branch and this feature branch, and usually feature branch 1 to 20, that will be merged into a single commit, and we just verify that everything is working together as expected. But each developer is able to work independently on his features, except if there are dependencies between features, then they have to use a slightly different model, saying that one branch would be started from another feature branch. But technically, you just work on branches. So another one, so always, always, always work on branches. So this means that you almost never commit directly to the main branch. So if you work with Git, every time you start a new development, even the smallest bug fix, you create a new branch, commit, verify that this compiles, this can be deployed, this can be tested automatically, integrated in another with other changes, and then when it's okay, you merge that onto the master branch. Except if you are absolutely sure, for example, you just fix a typo in the documentation on the README file on GitHub, you can commit directly to the master branch because there is no impact. Apart from that, you never commit directly onto the main branch. One very important tag is so when we commit, we just bring one tag to the new commit, and this is a head. The head is a very specific tag in Git, and it just points to a branch name. So one message that you can see, that you can often see here is oh, it's a bit later. So one thing. Did you already see this syntax for those already using Git or starting with Git, this syntax with ~0 or ~1 or ~2? Did you already see that? So this syntax is, I just would like to go back in time. So ~0 is one commit back in history. So here this is a 0 commit back in history, so this is directly the commit which is pointed by this tag. So head, this goes to DD8957CF. Head ~1, this is the previous commit of this one. So we will point to this one. So if you want to see what happened 5 commits ago, you can say git log head ~5, and you have this history here. So this tilde syntax is extremely often used, especially if you want to get back into the history, see all the changes from one commit to another one. This is extremely often used. So head, if you switch to a different branch, what will happen is that head will point to a different branch name. So here I was previously on the origin master branch. So if I create a new commit, the master tag will move along with the new commit that I create. Here I move to this bugfix branch. So the new commit will be started from here, and bugfix PCT366 tag will move along with my newly created commit. Okay, so head is always what you are pointing to. So we work with branches. So the entire idea is to have feature 1, feature 2, 3 on separate branches. So then you have to merge them onto the master branch. So how does that work? So here we have feature 1 and feature 3. As you know, you just need to, you want to merge those two features. So you have one tag going back to the origin of the repository. So the first thing that happens when you want to merge two branches, you will try to find the most common ancestor of both commits. So here, we can see that the most common ancestor is this one. So starting from here, this is exactly the same tree. Everything is common. Only the last commit is different in both trees. Okay? So you search for the most common ancestor, and then you will create a new commit with two parents. So the last one, so it will start from here and use those two parents as a base of the commit. So then Git will automatically merge the changes of both snapshots. So it will see, oh, there is one file changed in this version, one file changed in this version. Separate files, absolutely no problem. That creates a new snapshot. And if this is the same file but on different line numbers, Git will automatically create a new file with changes coming from both sides. And then if you modify the same file at exactly the same location, but if this is the same modification, no problem, Git will handle that. And then if you have different modification at the exact same location in the same file, then Git will tell you there is a merge conflict. You have to solve it manually. So before being able to create the new snapshot, it will tell you there is a conflict on this file, so please modify it, create your own version, you just solve the conflicts, and then it will be possible to create the new commit with the entire snapshot of the directory. Okay, so something that you have to remember is that when you merge a branch, there is absolutely no impact on the, here we merged feature 3 onto feature 1. There is no impact on this branch. There are no changes. The reason is that feature 3 and this commit doesn't know anything about children. This commit is a children of this one, so no impact. Here, it's still possible to continue working on the feature 3 branch without any impact. They don't know that this feature has been merged onto feature 1. It's completely independent. So this is what can happen then, is that feature 3, you continue working on that. So you just add new modification, but on feature 1, the developer will not know about what has been added onto feature 3 branch. So you have to continue merging, so in order to include changes coming from the other branch. So you have a new commit on feature 3, and then if you want to merge it again onto feature 1, then you have to find the most common ancestor. Here, the most common ancestor between feature 1 and feature 3, this is this one. And so then you will have to create a new commit with those parents, and the only changes that you have to apply onto the new commit is this one. This is the only one which is missing in the new in feature 1 branch. So here that will create this branch with the two parents, and here you apply this commit onto this one. So this is where Git is extremely powerful. It is at detecting what is missing when you merge multiple branches. And what doesn't work, usually almost never works with Subversion, is that you merge one time, the next time you want to merge, it doesn't work correctly. It's really a pain. And this is what works without any issue with Git. Except if you always modify the same file at the same location in various branches, then there is no solution for you. Yeah, and speaking of that, one thing that happens a lot, and especially on old code bases, is when you have a header at the beginning of the file summarizing all the changes on this given file. So if you do that on two different branches, you will modify the header on branch 1, modify the header on branch 2, and then you end up with a merge conflict just for comments. So you have to remove that. It never works. It never works with Git. So anyway, the point of Git is to make sure that you have the history of what is happening in your code repository. So just get rid of all the headers, and you can type the git log command line, and you will know exactly when your file has been modified and what happened, what is the ticket number, and so on. If you have meaningful git commit messages, then there is absolutely no need for this header. And that will solve all the merge conflicts that you will have if you merge branches with such headers. Okay? So never work anymore with such headers. Then, after the quick thing about branches, the branching model. There are many branching models. If you search for branching model on the internet, you will find multiple solutions. There is no one-size-fits-all when working with Git. It depends if you have to maintain a software that you sell to customers and you have to maintain hotfix branches for all versions. It is different if you maintain a web application that you ship directly, and there is only one active version at a time. It's different if you have lots of developers or multiple external companies working with you. You may have multiple branching models. So that will be the most important decision in your Git design process. That will be, what is the branching model that we're going to use? So Git flow is a famous one. It works well if you maintain a product that is sold to customers. If you only have to maintain one product internally for your factories, for in-house development, where you only have to maintain one version, there is no need to work with the Git flow for a branching model. You can use a trunk-based development, which is more or less like what happens in Subversion, except you have feature branches that you merge immediately to the main branch. So branches usually don't live really long. And then you have other branching model. For example, there is one that I've used multiple times for where you have all feature branches, and then you create release candidates out of 10, 20, 30 branches, and when that is validated, then the master branch will merge this release candidate branch, and this is how the master branch or the main branch will evolve over time. It can be useful, but this requires a bit of software to manage all the branches, to know exactly what goes into a specific release candidate, but it's extremely powerful. We won't have time to talk about that during this presentation. I could talk for hours on this topic, but you can come to me. I will be able to explain a bit how things can work. Then pull or merge requests. Do you know anything about pull or merge requests? So this is what pull request is what is offered by GitHub. Merge request is the equivalent in GitLab. It's just a way to have branches and have somebody else review the content of the changes and then validate that and integrate it into the main branch. This is absolutely optional. You don't have to use pull request. Technically, this is just a Git merge happening in the background on the server side. So you go to the web UI, validate the changes, click on the button that will execute a Git merge on the backend. It's absolutely optional. You can do that from your own computer without the need for GitHub or GitLab to do that. So if you read that pull requests are extremely useful when working with enterprise software, I wouldn't say that pull requests are extremely useful. So I would work in a different way. When working with web application, where you have to deliver very quickly, it's extremely useful. It's powerful. Here with open edge application, I wouldn't be so pushy about working with pull request. aliases. What time is it? Only 10 minutes. Okay, so I will go very fast about that. The slides will be available online after the conference, so I will let you copy-paste that. No need to take a picture. It's extremely useful to work with various command lines. For example, if you want to have the Git log, a colored log output, you can specify aliases. So those ones are extremely interesting. Go. Stashing is extremely useful, and this is a concept that many people don't use at all, while it's extremely powerful. So this is just a way when you want to switch from one branch to another one, you could have some pending changes. So using git stash, you can hide all your changes in a temporary location. Then you switch to another branch, do the required changes. For example, you modify one file, commit, push that to the remote repo, and then you can get back to the other branch and you unstash everything. So without having to create real commits and pushing them, you can keep a backup of your changes. Or that could be for test, unit test, or local things that you don't want to promote to the remote repository. You don't want anybody else to have a look at your local changes. So, because it doesn't bring any value. So using the git stash is extremely useful. The git reset is when you want to get back in time, and this is one of the first things that you will do at the beginning. The first thing you will Google or ask the question on Stack Overflow, how can I revert those changes? So the idea is that you will reset, you will have wonderful git reset command line, and you will say what happens in fact. So you will just reset your the head. It will point to something different. So you just point to a different commit ID here that will reset the local directory here, and then you can choose if you want to keep the changes or if you want to reset absolutely everything. So you just lose everything. So soft, hard, and mixed. Git LFS, I will go very quickly over that. This is when working with Git, you commit the entire set of files. So, and when you clone a repository, you have access to the entire history since the beginning of the repository directly when you clone. So there is almost no way using command line switches you can do that, but the default is that you do a git clone, you have access to the entire history. You don't have to connect to a remote server to have access to the history. This means that if you have large binary files which are changed multiple times over time, you will have all the copies locally in the .git directory. So this can become large over time. So usually do not commit binary assets onto the Git repository. And if you have to do that, because sometimes you don't have any other choice, you can work with LFS. So this is a way to say, this is a binary asset that will be pushed in a different location. So when you clone the repository, that will not fetch or download the entire set of binaries. So if you want to get back to one version, you will need server-side access to check out a specific version. So be careful when working with LFS. There is a burden on top of the existing workflow. Usually, do not commit binary things. If something can be generated, just store the source code and the process to generate the binary. So never commit any R code, never commit a database backup, or never commit a .db files. There is absolutely no value in Git. Squashing, something which is important, and all the developers do that. When you create commits at the beginning, this is the beginning of the day, so you create meaningful commits, commit messages. And then over time, just because you add fixes and fixes and fixes, at the end, you don't care about the commit messages. So this is when you develop on a branch. And who cares about all the steps that it took for you to achieve a successful feature branch? To add a new screen, it took you 10 steps to make that work correctly. Because at the beginning that was working more or less, then you verify, oh, that doesn't work correctly, I have to add a fix, add a fix, add a fix, add a fix. So on a feature branch, it doesn't have any value. On the long term, who will be interested in seeing that intermediate steps for a given feature branch? Nobody. So what you can use and what you should use is that whenever you are done with a feature branch, you should squash everything into a single commit. So you just say, this is this feature branch. So all the changes coming from this feature branch, you squash everything into a single commit. You then type a meaningful commit message with the right ticket in your ticketing system, something which is useful as a commit message, meaning the reason why you are changing something, not the content of the files, because this is already part of the commit. And then you just get rid of all those intermediate commits. So that nobody will see that it took you 2 days and 10 steps to get something done correctly. That will be, and there is no value on the long term. You just say, oh, new screen, new feature added. Okay, one commit that has been done at this date by this developer. That's all you need to know. And then that will free up some space in the Git repo. This is something in Subversion repositories many people do not commit often enough, just because they could be a bit shy about committing bad code into the repository, even on their own branch. You feel a bit shy when you are new on a product. Oh, I committed something stupid. Yes, okay, I don't want anybody else to see that. So here, you will be able to get rid of everything. So you can have commit every 10 minutes if you want to have milestones or local milestones, and then everything will be forgotten. You will only push the end result, okay? And then the rebase. We are a bit late about the rebase, but this is when you have branches that were started a couple weeks ago or a couple months ago. Usually you want to make sure that everything still works with the latest version of the product. So technically you can just rebase all your branch, all the commits in your branch on top of the latest version of your product. So technically you just rewrite the history and say, instead of having my commit started at this point in time, I'm starting here at this point in time. And then without having to merge the changes, you just modify the starting point of your branch, and then you inherit automatically from all the changes coming from the main branch. And you can test your feature branch in the context of the latest version of your application. Last point is about signing commits with SSH. If you configure Git on your local machine, you will have to type your name and email address. But technically, you could type your colleague's email address, and then all your commits would be under the name of your colleague. So you can make jokes, you can make fun out of your colleagues if you want, and commit under another name some stupid things. This can't happen if you add commit signature. So using SSH, it's possible to specify a private SSH key here to do or the public to do the SSH signature. Then this is pushed, and on the server side, there will be a verification that only signed commits will be accepted, and then it's impossible to spoof anybody else's name and email address in commits. That's very useful. I'm using 1Password as a password manager. This is, to my mind, extremely important to use a password manager in any company in order to have some shared password and private passwords. So I'm using 1Password. This works well. It is not really expensive. And there is a way to have signed SSH commits available directly from 1Password using fingerprints or Face ID or anything that just works. So use that, it's very interesting. We are now at the end. Do you have any questions? So I just hope that it brought some light on a few topics. This is not the usual GIT where I explain all the command lines, and so I just hope that you will remember a few things, a few key things important to understand how GIT is working. Any questions? Okay, I can see everybody is hungry. So there is a workshop this afternoon on VS Code. I have another session about VS Code tomorrow morning, if I remember correctly, and a session about Jenkins on Friday, first session of the afternoon. I hope to see you there. Enjoy lunch and enjoy the conference. Thank you.